שלום, שלום לכולם, אנחנו מיד מתחילים, אנחנו מתארגנים לוובינר בנושא כיבוי אש במוזיאונים ואתרים לשימור. אנחנו נמתין כמה דקות שיצטרפו אנשים, אני רואה פה שקצב הכניסה מרשים, נמתין. כרגיל מי שמגיע בזמן צריך להמתין, ומי שמאחר מגיע, רואה את ההרצאה בצורה טובה, אבל ממש נמתין עוד דקה קטנה. אני בינתיים מדבר כמה דקות על הנושא ועל המרצה. המרצה שלנו שמו רודיגר, מנכ"ל של חברת FOGTEC. FOGTEC מחולקת לכמה חטיבות. אנחנו בעבר היה לנו הרצאה של ה-FOGTEC tunnels, של המנהרות, היה לנו הרצאה של ה-FOGTEC trains, של הרכבות, ועכשיו רודיגר הוא המנכ"ל של ה-FOGTEC למערכות נייחות, למוזיאונים, למבנים, למבנים לגובה. הרעיון הכללי זה שכיבוי באמצעות ערפל מים הוא כיבוי בכמות מים מאוד קטנה, ויכול להיות מתאים לכל מיני אתרים שבהם יש לנו חשש יותר גדול מפגיעה, הן באוצרות היסטוריה והן במבנה עצמו. אז רודיגר, I'm presenting you to the crowd. I was presenting you in Hebrew a bit.
Thank you.
And let's take the time for that you will introduce yourself, and meanwhile other people will join. We have nice amount of attendees already.
Very good.
So,
Omri, thank you very much, and thank you very much for giving us the opportunity to introduce our fixed system for heritage building protection. I will share my screen just a second. Here we are. Right. So, today my talk will be about heritage building protection, but I will start with a short introduction of myself. Right. So, my name is Roudiger Kopp. I'm an engineer. My background is chemical engineering and safety engineering. I've been working in the water mist field for a long time, almost 25 years now. I have started working a lot on the research side, on the fire testing approval side of the system, and then moved towards the international sales and marketing of the system. I'm strongly involved in the guideline writing groups, like in NFPA 750. I'm a member of that group. I'm part of the European guideline writing groups, the EN 4972. I'm also a foundation member of the International Water Mist Association, the IWMA. So I'm been very deeply involved into water mist since a very long time. My role is here at FOGTEC, Fire Protection, the company I work for. I'm one of the directors of the company, and I've been with the company since the first day. So I'm also one of the founders. So just this a bit about my background. The company as such, FOGTEC Fire Protection, I heard that probably the one or the other has already attended another FOGTEC webinar here. Our company has been established in 1997 in Germany. We are located in Cologne, quite centralized in Germany. As a company, we are very much involved into engineering. Of course, we are also producing the systems. We have a manufacturing site for the pump unit, section valve, all the related components. But with water mist, it's different to conventional sprinkler technology, for example. It's very much an engineering approach you have to take. All the standards, I will talk a bit about that a bit later, are not prescriptive like you know it from sprinkler, but they are more performance-based. So companies like us who want to develop a system and bring this system to the market, we have to be strongly involved into the design engineering of the system and have to validate our system in full-scale fire tests. We have been conducting such fire tests since the last 20 years for all different kind of applications. So today, of course, we have a quite broad application field we can cover with the fire test results we have available. And we bring the system technology to the market via partner companies. In Israel, Paragon is our local partner. So our partners are working very closely with us in developing fire protection concept, into selecting the right components, doing all the engineering around the system, including the hydraulics and so on. And they are the final company then who integrate the system, who install the system, and of course offer all the maintenance service around the system. So this is how we are set up. And yeah, I hope this gives you a good idea who FOGTEC is. Now, what would be interesting for me as a presenter here is to learn a bit more about who our audience is today. So it would be interesting for me if you could give me a bit of an idea what is your professional background. And we have come up with a poll here. You see that, I believe, on your screen. So for me to understand better what would be your interest, your needs in this webinar, it would be very helpful if you could fill in this. And because, of course, an architect has a different approach maybe as a fire service or the system operator. So take your time and yeah, make your choice here so I can get a good understanding what kind of crowd of people we have today in this webinar. All right, so I think we have a good mix. I can see here that we have quite a number of architects with us, so that's very good because my presentation will include quite a number of case studies, so you will see how the water mist technology actually has been used for protection some buildings. We have quite a number of fire consultants also with us. Also, this is very important for seeing and understanding where the benefits of the technology, and we have a few fire services with us as well, and some system designers. So it's a good mix of all. So I'm very happy to see this. And yeah, this is where I will start with my presentation. So the agenda is, just a second, there we are. Yeah, I will first of all give you a bit of a background why fire protection for heritage building is so important. And water mist is not completely new to this field. This is one of the first fields where water mist technology has been taken into the market, where there was a request by the market, by consultants, by clients, for a technology which uses water to fight fire in a very sensitive way. And I will give you a short introduction why we see water mist as a good solution there. And then I will speak briefly about how the technology works, where are the benefits of the technology, before I then come to the already mentioned case studies, where I have quite a number of those in different fields to give you a good idea. And then I will come up with a conclusion of my presentation, and at the end we will have sufficient time for question and answers. So please already provide now your questions. I think you can type them in, and we will answer them in a question and answer session at the end of the webinar.
Yes, they can ask the question. They have the Q&A, and after the end of it, we will gather the questions.
Very good. Very good.
Sorry.
Yeah, thank you, Omri. Yeah. So, yeah, what is the motivation actually to install an active fire protection system into a heritage building? Now, there are unfortunately examples, very bad fires into such buildings. One of those is on the screen right now, which you definitely all know. In 2019, the very tragic roof fire of the Notre Dame Cathedral in Paris, which developed very fast. The fire spread out through the entire roof structure. And fortunately, the Paris Fire Brigade could limit it to the roof structure so it didn't spread to the entire building. But of course, such a fire caused a tremendous impact to the building, and there was a great loss of cultural property, although the fire brigade has acted so quickly and so successful. So this is, of course, not the only fire in such environments. Over the last 20 years, we have seen such fires in many different places of the world, and all all of them have been very tragic and have caused a lot of destruction. So obviously fires happen, and there is a need for fire protection for such buildings. But historical buildings are very sensible structures. So fire protection is something that really must be looked at in such a structure, because often fire protection has not been a key focus when these buildings have been built. And so the whole building in many cases is one complete fire zone. There are no partitions into the building. So if a fire starts, it very easily can travel throughout the building and cause substantial damages throughout the structure. So fire spread very quickly. In addition, we can have very different type of fire loads in the building. A lot of these historical buildings, they store old goods, documents. A lot of them are used as archives, as libraries, but also a lot of them are used as museum, where you have very valuable goods, and these goods can be of very different kind. The building structure as such can also vary a lot. In many cases, wooden structures are used, which of course can also have a strong impact on the fire, particularly if wooden floors, for example, are used. So fires can propagate in such areas very quickly and cause substantial damages. And mainly this missing compartmentation between the building either requires that the structural measures are improved, so that fire-rated doors are installed, fire-rated walls are installed into such buildings. But this, in many cases, is very difficult to achieve because you don't want to interfere too much with the building structure. So actually then an active firefighting system, an automatic firefighting system, can be a solution to the problem. And in most cases, it's a kind of combination of that all. And of course, this also is done to allow self-evacuation for people who are in the area, and also safer approach of the fire services to the building. So what is key in all these projects is that there is a detailed fire risk assessment first before a system is offered, because there's no universal approach to fire protection in heritage buildings. They differ so much from each other. So it's always a custom-made, a tailor-made solution in regard of fire protection for the building. So water mist in the last 20 years has developed as an interesting technology for this kind of environment, due to its high cooling ability and also partly smoke reduction, so limitation of smoke spread throughout the building, but also doing this with the minimal amount of water. And this, of course, then prevents large water damages, water runoff in areas which are not directly affected by the fire. So this is something that we will talk about today. But water mist also can have some cost saving into such historical structure, particularly because they are retrofit installation, and structural measures like cladding for wooden structures and so on are often difficult to be achieved. And this is where water mist, by its high cooling ability, has a chance to compensate such structural measures, which in the end leads to a good solution for the problem. So before, I will then start with a building, with the case studies. I want to give you a run through the water mist technology with the key aspects, why this technology is so interesting for this kind of environment. And what is this whole water mist technology about? So in our cases, we are talking about high pressure water mist technology. What we are doing with our pressure, with a high pressure, we are atomizing the water into very small droplets. As you can see on the graph below, the water, instead of just being sprayed into the area, it is atomized into minute droplets, and the cooling ability of a firefighting agent happens. This is something that is directly related to the surface area made available, because there you have the interaction between the fire and the firefighting agent, the water. And due to these very minute droplets, we create a far larger surface area with the same quantity of water. And due to that, we have a substantially higher cooling effect than a conventional sprinkler system. So you see this graph on the left lower side. This is actually from a real fire test where the fire was ignited. It was left for quite a long time of 15 minutes. So the fire developed very strongly, and temperature will reach of 700-800 degrees. And at the red line, the system was manually activated. And you see in a very short time, less than a minute, all temperatures in the entire environment drop below 50 degrees centigrade. And this is what in general you will see with water mist technology. You have a very rapid absorption of the heat of the fire. And by this, of course, the fire is suppressed. You have an immediate limitation of the fire propagation, which is key, particularly in the environment, in the heritage buildings, which we are talking about. But also this high cooling effect improves the evacuation conditions for people who are in the area who have to self-rescue themselves, and also creates a safer environment for the approach of the fire services. So this cooling effect is a key effect of water mist. And this, in the end, of course, also protects building structures from the radiation of a fire, the heat radiation. So building structures like an exposed glass structure can be cooled and can be preserved from the heat radiation. So we have a number of cases, I will come to this during the case studies, where instead of fire-rated glass, we could use ordinary window glass in combination with the water mist system, which in the end has then also a very positive cost impact, reduces the cost, overall cost of the system. But by atomizing the water into these small droplets, we only use a fraction of the water than a conventional sprinkler system. So you see on the top photo, this is how a sprinkler works. It sprays the droplet. It is a good system. It works, no doubt about that. But this technology has not been improved so much the last 100 years. So it does the job, but it does the job with the same water quantity that it did 100 years ago. And the standards are very prescriptive. This is why the technology also does not have a lot of chance to develop. And this is where the water mist technology is really different. In high pressure water mist system, you see it on the lower pictures, you produce very, very small droplets, and this allows to reduce the water amount substantially in comparison to a sprinkler. We only use about 10 to up maximum 30% of the amount of a sprinkler. So we're talking about 70 to 90% less water consumption as sprinklers. And of course, you can imagine in an environment like a heritage building, this is key for the building operators to look into the technology, to make it attractive, to preserve and prevent water damages in an area. And what is also different to water mist, it is not a pure two-dimensional system. So it does not only spray on the surface, but it fills the whole volume underneath the nozzles. And it's almost three-dimensional in this field. And it also reaches some hidden spaces by that. So this is another benefit which can be seen in obstructed areas in the area. And this little amount of water, of course, has a positive aspect for the building structure as such, but mainly also for all the exhibits in the area, for documents you have there. If you have paintings, for example, in art galleries, this is seen very beneficial about water mist. And it also has a positive aspect if you have some exposed electric components in the area, because the risk for short circuit is also minimized. As a following, I have a short video which shows a bit the difference. So you see here the discharge of a conventional sprinkler system. It's really like rain. It sprays from the nozzle. And now you see the high pressure water mist technology. It has these very small droplets, but it's not really that they spray on the floor. They fill the ambient and have this immediate cooling effect. And this is really a great difference. You see the room here is a demo area where a lot of customers can stand inside when the water mist system is activated, and they are all surprised how little water is discharged from this kind of system. So, but water mist is also not a completely new technology. It's been around, as I said, since more than 20 years now for building protection. So there are a number of standards which are used as a design reference for the system, which are also used for an approval and certification reference of the system. On the one hand, there's the American standard, the NFPA 750, which has been around since 1996 now already, which is used as a reference. In Europe, the EN standard 4972 is referred a lot. And then there are national standards, like in Germany, we have the VDS 3188, which regulate this type of system. Now, what is different in this standard, different to what you know from sprinkler technology, like the NFPA 13, is that it's not prescriptive. You won't find in the standard details on what is the maximum distance between the nozzles, what is the maximum installation height, what are the K factors of the nozzles, what are the minimum pressures, because this all is very much related to the supplier of the system to develop its own system, his own system around this, and then the supplier has to prove that the system is able to carry out certain measures like fire control, suppression, and extinguishment in full-scale fire tests. And this is where water mist is the only technology where all the systems that are provided to the market, are offered to the market, have to be 100% full-scale fire tested and validated. And this is what we have been doing in thousands of fire tests since the last more than 20 years now, for applications like public spaces, like offices, hotel rooms, but also storage areas. So when we talk about the building protection, like what we are doing today, we are talking about OH1 to OH3 type of risk, where the system are independently tested and certified. We have a lot of VDS certification for our system. And this, as I said, is a state-of-the-art technology today. So it's nothing new. It has been used by many clients throughout the world based on these fire test results and the approvals. The nice about the technology, particularly if you look into the life cycle cost approach, is that we are using very high-grade material for the installation. So all the piping that is used in the system, but also all components which are in contact with water are made of stainless steel. So they are corrosion resistant, and this makes the system a very long-lasting system. It has very long lifetime and makes it interesting under this aspect. And this also due to the small water usage, but also this long-lasting material, it makes it a sustainable technology, which is environmentally friendly because it uses water with care. So I hope you can hear me. Yeah. Another aspect is that the system is quite versatile and flexible to be integrated. It has a high system flexibility. It has a modular approach. So the system is set up similar to a sprinkler system, we can say. So normally you have a centralized pressure makeup unit, a pumping unit, which is usually installed into the basement of the building, but especially for retrofit into historical historical buildings, we had a number of cases where there was no space, no possibility to install it into the basement. So we, for example, installed it in the roof area of the building. This is also possible with the system because the equipment is quite compact, it's quite modular. We don't usually have very large storage tank. In many cases, the tank sizes range in a few thousand liters. So you see the picture here on the bottom right. The stainless steel tank there on the back has a volume of 3,000 liters. So it's very compact. And this thing, the system you see there protects the entire building. You have the pump unit in front and the controllers behind it. So maybe on 10, 15 square meter, you can place this whole pumping equipment, which makes it quite advantageous to be integrated into an existing building. From there, you have a riser, you have the distribution pipe work going into all protected area. Per floor, normally a zone valve, a section valve is installed, similar to sprinkler technology, which on the one hand gives an alarm if a glass spout nozzle, an automatic nozzle, has been activated, but also gives a chance to later extend the system from that point onwards into additional areas that shall be protected. And all the piping, as I already said, is made of stainless steel, but it's also very small in diameter. And this makes it, again, very attractive for heritage area because you can hide the stainless steel piping quite well. We are talking about 12 millimeter pipe, so like a finger in size. For the pipe towards the nozzle. The main riser into a building, in worst case, has something like 2-inch size, 50 millimeter. So it's very compact and can be easier integrated into existing building structures. And from the distribution piping, you, of course, then install the nozzles. In many applications, we are using automatic nozzle, glass pop operated nozzle, similar to a sprinkler nozzle. You have a thermal activation element into the nozzle, which breaks by the heat of the fire and then discharge the nozzle, but individual nozzle, like with the sprinkler system, only in the area where the fire has happened. So you are not spraying water mist into areas which are not in the fire scenario. And if you compare this with conventional sprinkler technology, we have the other benefit that the coverage area per nozzle is also larger, up to 25 square meters in comparison to sprinkler. So you have less nozzles to be installed, which again is beneficial. And today, these nozzles can protect heights up to 12 meters. So even if you have a larger auditorium area, in most cases with a ceiling mounted installation, it is possible with water mist. These systems are then often combined with wall hydrants, which are also working with the same technology, which are also atomizing the water by a special water mist gun. We call it fog gun. And this is for fire services. Of course, they have to be trained on this to approach the fire and to tackle the fire and finally extinguish the fire, but using a very little amount of water. So by that, also reducing the collateral damages to a minimum. That's the idea. So this is the approach in technology-wise. And I believe this at least gives you a good outline, a good understanding how the technology is integrated to the building. Now, before I come to the next part, to the case studies, I would like to ask you an additional question. And this is, since a lot of you are also architects, what are your concerns actually to install an automatic firefighting system into a heritage building? So we have seen this in the beginning about 20 years back, that there's a lot of concerns of using conventional technologies due to different reasons, and we just summarized them here on the slide. Maybe you can tick a bit the boxes to give me an understanding how you see active fire protection system for heritage buildings. We will wait a minute. I assume that most of the concern will come from the potential water damages. This is at least what we heard a lot in the early days. But also in a heritage building, if you have very valuable ceiling structures, gypsum ceiling structures, painting on the ceilings. It's also very difficult to install the piping, and that's where water mist really has a benefit. Yeah, that's what I expected. So most of you think there's a concern about water damages, and indeed, this is something that would happen with a conventional sprinkler system. It will tackle the fire, will take care of the fire, but of course, there's a lot of water runoff, which can cause a lot of damages. But also, then from the integration point of view, I think between the points, pipework installation, places available to install the pumping and water storage equipment, and also cost considerations. These are quite equal in your poll here. And indeed, all of these can be a reason why there's a concern for the building. And yeah, what I want to give you in the following are some case studies to give you an understanding how you can tackle this with the water mist. So water mist, when it has been taken to this kind of heritage building environment, first of all, it has been seen for applications where the documents or the equipment that you have in the building is very valuable, and where the concern was also with the building, but mainly it was with the goods that are stored in the area. So this is where applications like libraries, archives, but also museums have come up, and a number of the applications or the reference you will see, they have been already equipped with water mist about 15 to 20 years back, so quite a number of years back. These were the initial application fields, but more and more other fields have joined, like concert halls, theaters, municipal buildings into historical buildings, and also luxury hotels, particularly those where an existing heritage building is turned into a hotel structure. Then, of course, an active firefighting system is key. An automatic fire protection system is normally specified by the authorities, and this is when it has to be integrated to the building. And I will also show you some case studies there. The building you see there is one of the first installation we did in Italy. That is also full of documents where the system has been installed to protect the archives. But coming to the first one, and this indeed is an application where we have installed the system more than 20 years back, so quite a long time. The system is in operation. It is the Municipal Library in Trier in Germany. It's one of the most significant library for historical books and documents in Germany. They have a great collection with 750,000 of books stored from the last 1200 years. So a lot of old Bibles, you see that on the lower left picture, very valuable books they have there. In total, they estimate the value to be around 250 million euro. This building was erected in the 1950s, but up to the late 1990s, it actually did not have an active firefighting system, an automatic firefighter. There was detection installed, so they knew if the fire happens, but then they were relying on the fire services to approach the site and to carry out final firefighting measures, usually, of course, using a lot of water. And this is where the local authorities had great concerns and requested to retrofit an automatic firefighting system to the buildings. We are talking about 7-floor buildings, and it takes quite a while at the fire brigade approach to reach all the areas to tackle fires. So the fires normally would have spread and caused a lot of damage. So this is where different technology were looked at. Also conventional sprinkler technology, gas extinguishing technology was looked at, but also water mist in the early days when water mist started to be a solution for the buildings. And we had to carry out full-scale fire tests to demonstrate the ability of fighting fires. This was not a concern, they saw it, but the customers in this case, they were concerned about whether water mist would also discharge too much water on the historical book, that they would get damaged. And that's where, beside the fire test, additional discharge test were carried out on older documents to see how wet the documents get when the system is activated. And they actually found that after a vacuum freezing process they normally use to dry such documents, that the documents were hardly affected. There was no negative effect when water mist was discharged. So they were very happy about these results. And this is where they finally decided to equip the entire building with a pre-action system. So on a standby condition, there's no water in the piping. So they didn't want that. So only if the fire detection system picks up the alarm, then the pipe work is pre-filled and it starts to discharge water when the glass bulb nozzle is activated in the area where the fire actually happens. Yeah, so this is the approach they have taken, but they also said, well, if the fire brigade approaches, we want to make sure that they extinguish the fire, not using large quantities, because then the whole benefit of the water mist system would be gone. So the system has been combined with these special hydrants, with the water mist gun, the fog gun integrated. You see that on the lower right photo. And so the fire services have been trained on this. So once they approach the site, they arrive, they pick the gun and finally carry out extinguishing measures into the area. So this has been the approach, and the system has been up 20 years. Fortunately, they did not have a fire in this time, but they are very happy and feel very safe with this system installed. And in a very similar environment, we have installed a system in Bilbao, in Spain. The municipal library there consists of a heritage building, an old building, you see it there, from the 18th century, which was modernized by extending the library behind the building you see on the top with a modern structure. That's the lower left picture you see there. There's a glass structure which is just behind the building. And this extension requested the whole building to be retrofitted with an active firefighting system. And this is where, again, they looked into different technologies, but with the same motivation as the previous client. They saw water mist as the best solution because it's little water usage, little collateral damages it would have, and also particularly for the heritage part of the building, the small piping to install the system along walls and ceilings to not interfere the heritage appearance of the whole building. So this is where they have been very happy. A challenge, like in the previous one, have been the sliding shelf areas, like you see on the lower right picture, because once the shelf is completely closed, how can the water mist penetrate inside? So the concept in such an area is that ceiling mounted nozzles are installed, that in the area where you have the gap, like you see on the right side, water mist can penetrate there and can limit the fire spread from one shelving area to the neighboring one. But then this building has also been retrofitted with the water mist handheld guns for manual intervention by the fire services. And once they approach such an area with sliding shelves, they would open up the area where the fire has happened and can manually tackle it, but using very little amount of water. Again, that concept has been followed in this reference. And similarly, it has been followed into this building. This is a very old building from 1757 in the city of Turin in Italy. It's the Scientific Academy. This actually houses a lot of ancient documents, more than 60,000 documents from the last 400 years, including public entries, patents, and so on. Very valuable goods. Here, the same reason has been little water usage, small bore piping to not interfere with the heritage structure of the area, the heritage appearance of the ceiling, as you can see there on the lower right picture. But the lower right picture actually has also been the challenge in this project, because we have quite high ceilings, up to 7.5 meters. So where a special approach had to be developed. And this is what I said initially, water mist allows for an engineered approach to this. So that's where specific fire tests were carried out. In this case, we don't have ceiling mounted nozzles, but we have sidewall mounted nozzles being installed in different levels along the sidewalls, where, of course, the books are stored, so where the main fire risk is, but also spraying into the center and making sure that this whole auditorium is protected in an adequate way. And this, of course, then is also always accompanied by a fire consultant, which then looks into the fire test results and approves the kind of concept for the building. Again, here we have then combined this with the water mist gun for manual intervention by the fire services. A very large archival structure which we have protected, you can find in Paris. That's the French National Archive. Into the building you see there are 320 kilometers of shelves which are protected. You have different kind of documents. There are paper documents, but they are also storing tapes. So there's also kind of plastic fire loads. That's why the customer requested for specific full-scale fire tests to demonstrate the ability of the system, which was done for this project, both for fixed shelf as well as sliding shelves. So the concept has been verified before the installation into this building. And in total, into the high building you see behind there are 200 archives of each 200 square meters. So we have a total protection of 40,000 square meter plus the office areas in front. So in total, 48,000 square meter of protected area. Quite a large installation into such an archival environment. But the customer is very happy. This system was also installed more than 10 years back. So, and it also allows for an extension. So they actually are looking into further extending the areas to be protected. And this modular layout, which I presented before, allows for that. So they have the section valve installed, and the piping behind the section valve can be retrofitted, can be installed at a later stage. Yeah, I was also mentioning museums. So, of course, museums with the water-sensitive goods, exhibits are key for a system which uses little water. And here's one example from Italy, in Turin, the Egyptian Museum, which was erected in 1824. So a historical building as such, which is of course also listed, but inside it has the world oldest and largest Egyptian exhibits in the whole of the world. So it's more than 30,000 exhibits, which a lot of them are water sensitive. So papyrus rolls and so on. You can imagine if you spray water on that, that's a disaster. And this is again where the client has looked into a system which uses as little water as possible, but being as efficient as possible for the area. And today, a water mist system, high pressure water mist system, is protecting all the exhibition areas, all the office throughout the building, again in combination with the water mist guns for manual intervention by the fire services. Art galleries are also a target for the technology. So the Royal Museum of Fine Arts in Antwerp in Belgium, also a historical building, as you can see here from the 1890s. It houses and conserves more than 7,000 paintings, sculptures, and drawing of the last 700 years, very valuable goods. And particularly in the area where the goods are stored, you see that on the lower right picture, they were looking for a good solution. A gas extinguishing system was not seen as a good solution here because especially deep-seated fires are not taken care of very well by gas extinguishing system. So a sprinkler, obviously, they didn't want to discharge on the area because of the large water consumption. So water mist was selected as the best possible option to protect the atelier, the storage room into this building. So again, the same reasons, but you can see here the variety of the system. And another museum in Germany, this one in Moers, close to Cologne. This is an old castle, which is used and operated as a museum today. It houses very valuable artifacts in wooden structures. The building as such has wooden floors, so valuable floors, and it has a wooden attic, as you also can see on the lower left picture, which is always a challenge because into this area you have an exhibition area, so people are also walking into this and have to find escape routes. In addition, this whole building only has one escape route, so this was a major concern, and the local authorities requested for an automatic firefighting system to compensate this, to make sure that people inside of the building in case of fire can safely be evacuated. And it was very challenging to install the system here because there's very little space to run the pipe, but the key challenge has been to find a room where to install the pump unit and the water storage tank. In total, the whole pump room and water storage area for this building has about 6 square meters only, so it's very compact, and such similar applications we had in other countries as well, where only very little space was available for the pumping equipment, the water storage equipment, and this is where water mist turned out to be the best solution. So a system was installed on all 5 floors of the building, protecting the total of 2,000 square meter floor area, and again it is a very discreet installation, almost invisible in regard of pipe installation, which was also a key for the conservators of the building. Yeah, we have here a university building in Vienna. It's the University of Applied Arts. Also, that is a heritage building structure. You see that on the top, but that one again was also extended by a modern structure behind the building. That's what you see here on the lower photos. On the left one, you see the atrium into the building. Now, here we had a real challenge because this area is quite high. So we had to again come up with an engineered solution. They were concerned about the inner glass facades, what you see on the lower right photos, where the glass they used is ordinary window glass, and they were concerned about the fire affecting this and breaking it and then having a smoke spread throughout the building. And this is where water mist has been seen beneficial in tackling such fires, reducing the heat radiation to the glass, and by that protecting such areas efficiently. And this has been installed throughout all the glass facades within the building to create a safe environment for the building. Yeah, coming to the concert halls, this one is quite famous. It is in Hamburg along the river of Elbe. This is the new outstanding building in the city of Hamburg, one of the world's best concert houses in regard of the concert hall as such. The whole building is quite large, but the real challenge into this has been the main concert hall, which you see on the lower picture. This is an area with 2,200 seats, but with a height of 25 meters. So a ceiling mounted system into this area is impossible to install. A sprinkler system was not a choice because of potential water damage, but also water mist could not be installed in the ceiling into this. So again, we had an engineered approach here with floor mounted nozzles, which are installed along the seat rows. They are normally covered by a lid, and only in case of fire detection, the system is activated and water mist is sprayed from the bottom upwards to protect the area. But the fire load is close to the seating, so it's not in the air volume above. So this concept, of course, has again been validated in full-scale fire tests, and the consultant involved, the fire services involved, all parties involved, the clients, the insurer, they all have accepted the solution, and this is how the building has been protected. And this kind of concept has then been used for various other buildings, which I will come to in a minute. Again here, a theater the Kaisersaal in Erfurt in Germany, a very old building from 1808. It has been used by famous German classic writers like Johann Wolfgang Goethe or Friedrich Schiller have already been into this building. Again here, little water usage has been key to protect the building from potential water damages. And this has also been the case in Venice, in the La Fenice Theater in Italy, in Venice. This building has had 2 fires. It was initially opened in 1792 as a listed building, but then there was a fire in 1836 where it was destroyed and reconstructed. And then in 1996, there was a second fire into this with severely damaged the building. And this is where it was decided, of course, to install an active firefighting system. Again, water mist has been seen beneficial, particularly into the attic area here above the concert hall that you see on the lower picture with very valuable ceiling structure you see there. And they were concerned to use sprinklers, conventional sprinklers in the attic, because the water discharge would soak into the gypsum structure and would cause the whole ceiling to collapse. And they were then happy, of course, to use a system which used potentially or much more less water than a sprinkler system to protect such areas. And this is a similar concept that has been used in a German theater in Hamburg here, where you see also the type of structure of the building is very similar. Again, this concept has been used. And this system has been combined with the floor-mounted nozzles, similar like the Elbphilharmonie in Hamburg. Into this building, you have a combination of nozzles installed into the area which can be protected with a ceiling installation. And in the audience area, as you can see there, there's this floor system, which makes sure that in case of a fire, water mist is discharged from the bottom up to protect the area, to safely make sure that people can safely be evacuated. Similar concept has been used in the Spanish Congress building, as you can see here in Madrid. Also there we have quite a high ceiling height. This building is also heritage building from 1850s. So the little water usage has been the reason to install the system into all offices areas, the public spaces, but also the auditorium, the attic into the building. And here again in the auditorium, we have this combination of floor mounted nozzles and ceiling mounted nozzles in the areas where they can be installed. Same has been followed also in this project. That's the town hall in Madrid called Cibeles in Spain. Also a historical building which was initially built as a postal service headquarter and turned into the town hall, which requested the building to be retrofitted with an active firefighting system. And this is where the whole building has been protected by a water mist system. Again, a challenge here has been the areas with a great height of up to 19 meters. No ceiling mounted system could be installed. So again, a combination of the floor mounted nozzle into the area you see on the right low picture has been installed, and on the low left picture sidewall mounted nozzles have been installed. Again, the whole validated by full-scale fire tests. So this has also been the case here in the palace at the St. Mark's Square in Venice. You certainly know the picture. So the building on the left, which you see on the lower picture, also this entire building is protected by a high pressure water mist system. This whole thing has been restored, this very ancient building from the 16th century. It is today used by Generali Insurance as their headquarter, and David Chipperfield as architect has redesigned the system. A very careful redesign has happened, and this is where water mist was integrated without interference into the structure of the building. So the very filigree piping has been key. The pump unit in this kind of building is installed on the roof, in the roof area, in the attic area, because there was no other space to install it. Coming to the last cases, which are hotels. As I said, it's especially if you have historical buildings which are retrofitted into hotels. But in this case, it is a building which always has been a hotel. It's quite old. It's from the 1486. Already then it was operated as a guest house. This today is a Radisson Blu hotel. It's called Schwarzer Bock in Wiesbaden in Germany, one of the oldest grand hotels in Europe. Historical building. Here all the rooms, hotel rooms, 142 we have in the building, but also all the public areas, the restaurant areas, all these areas are protected with water mist technology on 6 floors. They have very valuable wooden floors. So using little amount of water has been key to integrate the system, and also not seeing the piping, not interfering visually with the architecture of the building has been key. And this is very similar for this building. That's even a building from the 1830s in Scotland. The Cameron House Hotel, very high-class hotel, 5-star hotel. This had a severe fire in 2018, and when it was reconstructed, an active firefighting system was integrated. Again, water mist was seen beneficial because of little water usage, filigree piping. You don't see it under normal conditions. So this is where it was seen beneficial. And as a last application, I will come to an application in Israel, where jointly with Paragon, our local partner, we have installed a high-pressure water mist system into the listed heritage building of Baha'i World Trade Center in Akko. This is, as you probably all know, a listed building, and based on the huge fire in the Notre Dame in Paris, they decided to install an active firefighting system, an automatic firefighting system, in combination with the refurbishment of all the entire electric system of the building, to make sure that in case of a fire, the fire is taken care of with as little collateral damage as possible. And this is where the system has been installed in the attic, in the first floor, and in the store area in the ground level. So from what you've seen, I just want to conclude what I said. So what is important for heritage area is that there's no universal solution to fire protection for these buildings. So the risk assessment has to determine the best way forward. And you've seen that there are many different approaches with ceiling mounted nozzle, with floor mounted nozzle, in combination with these wall hydrants, with the water mist guns. So different concepts have to be developed, but sometimes, of course, also combined with passive fire protection means like claddings, for example. Fire detection is important, and also this all has to be agreed with the fire services to find an acceptable solution to mitigate the fire risk. But water mist has been seen and identified as one of the best suited agents when it comes to an active firefighting system, an automatic firefighting system for such buildings, due to the high cooling effect that we have, the compact sizes for integration, mainly piping and water storage, and also in case of an activation, the minimized consequential damages. And it's seen beneficial also because with one technology, all risk areas within the building can be protected, where in the past, maybe some areas are protected with a conventional sprinkler system, others with a gas extinguishing system. And here we have one solution which can cover all. So this is where I want to conclude my presentation, but I would be very much interested to hear from you what you are taking from this. So what are the takeaways when you have heard this and have seen the reference cases? So where do you see the benefits of water mist technology when protecting heritage structures? So we have another poll coming up, and maybe you can just type that in to give us also a better understanding how you see, how you value the technology.
Okay, everybody will vote now. After they finish the votes, I will ask the questions that I gathered throughout the lecture.
Very good.
I can tell you there are many questions, but I will use only 3, and all the other questions will be answered. Sam will send the people, the attendees, his details, and he will contact them and gather the questions, and that can answer them.
Very good. So let's see what the results are. Right. Yeah, so most of you see water mist beneficial because of less collateral damages by water runoff and water effect on the exhibits, on the goods like archival documents in the area. And this is indeed the main reason why customers have gone for water mist technology in this application field. So I hope this was interesting for you, but I'm now also happy to take your questions.
Yeah, it was very interesting. I will ask, the first question is, what is the minimal pressure for the system?
Yeah, so in our cases, our minimum pressure is 60 bar. So we use the pressure to do 2 things. One is to atomize the water into small droplets. And you need a certain energy to produce very small droplets. You can also do it at lower pressure, but then you don't get these very minute droplets. But what is also key is that these small droplets have to reach the fire. Yeah, and to make them travel from the nozzles, which can be up to 12-meter height, as I said, down to the floor area where the fire happens, you need to get the droplets to give them a kinetic energy to accelerate them. And this is what is used with the pressure energy to split the water and to accelerate the droplets so you can overcome great heights, but still use very small droplets. So our minimum pressure we operate at is about 60 bar.
Okay, there is one question that I think it's not related to this subject. It's someone asked if we can use water mist for room with lithium batteries. I think that's, I will address this person and whoever interested to Paragon page of in the YouTube. You press Paragon Academy. We have a lecture of Max that spoke about it, 50 minutes, about lithium batteries.
Very good. But this is one of the key development fields at the moment for water mist technology.
Yes, I know. We had a nice lecture of Max regarding that. And there is another question. Why there is someone asked, because in Israel, most of the buildings are made of concrete and glass, and we are less concerned about the buildings. We are more concerned about the collection. Someone from Israel Museum asked from Jerusalem, asked about what is can you say about the pros and cons for water mist and gas systems?
Well, with the water mist, of course, we are still discharging water into the area, but we are doing it very carefully, very sensibly, with very little amount of water to a minimum possible. And this then achieves this high cooling effect that I was saying to fight the fire. Now, a gas extinguishing system works on completely different principles. It discharges the gas into the area. It's not the cooling ability of the system which fights the fire, but it's the oxygen displacement effect. But to get this oxygen displacement effect, you have to seal off the area first to discharge the gas into the area to achieve the reduction in oxygen level to fight the fire. And this time it takes to evacuate the people, to seal off the area, this is the time where the fire can further create damage and further spread. And this is where we at least have seen over the last 20 years, where users, customers, fire services, insurers, consultants see a water-based technology as the more safe system because it has less collateral damages. A gas extinguishing system, once it's discharged, it does not affect so much the equipment inside, but before you can discharge it, the fire damage is already larger. Yeah? So, and this is where we very seldomly see a gas extinguishing system in historical building protection. So if we talk about archive libraries, where you have people constantly going in and out, a gas extinguishing system may be used into a storage area where you don't have people presence, where you don't have people walking in and out.
Okay. And of course, if the volume is not so big.
Absolutely. The larger the volume is, it gets also very expensive. Yeah. So because you have to always fill the entire volume with the gas. Yeah. So the larger the volume gets you want to protect, the more expensive a gas extinguisher system gets. And then water mist system is far more cost effective.
More expensive and less effective, let's say.
You can say so.
Big.
Yes,
Yeah.
correct.
And one last question, because I see a lot of questions that we will answer it locally. Why not using an oxygen reduction system? Because few people in museums and preservers, they ask me, this is a very good system. It's one reason I will say it is not, doesn't have the standardization in Israel, but this is also something that can be solved. But if you can install two systems, but why not using oxygen reduction system?
Well, oxygen reduction systems are very good systems. Yeah? But again, similar to a gas extinguishing system, you have to make sure that you don't have great openings into the area, because otherwise you will have a lot of running cost also to generate the nitrogen, which is pumped into the area continuously. Such a system is very good if you have a sealed off area without a lot of people walking in and out. Yeah? But if we are talking about museums, archives, libraries, hotels, such a system is not really feasible. Although technically it's great, but because you constantly open doors and windows and so on, you cannot really build the right concentration of gas, or to reduce the oxygen content that much continuously that the system would work efficiently.
Okay, Roudiger, I would like to thank you for your time.
Thank you for your time, for attending this, for the opportunity for FOGTEC to give this presentation. So I hope this was interesting for all of you, and we are very happy to answer additional questions once they come up. Huh?
Yeah, it was interesting even to me that it's I think it's the 30th time that I hear this lecture, but it was always interesting.
Very good. Thank you very much.
Thank you.
And
have a nice day.
Have a nice day. Good evening. Yeah, bye-bye.
Bye.
Bye-bye.